So somehow you'll have to go back and find it, but we need to get moving on our practice. So let's start with number one. We're not going to do all of these. We don't have time. We're practicing because the next time we're together, we're going to have a little quiz over exponent problems, like we did in our notes and like we're doing here. Okay? So, first thing I see is I've got a fractional exponent. What does a fractional exponent always mean? A radical. So it's going to be a radical. And underneath the radical is going to go 16x squared. And the radical is going to be the square root to the first. So what's the square root of 16? 4. What's the square root of x squared?
X.
Done. Problem finished. Moving on. 9 to the negative 3 halves. Now this is a negative exponent. So we're going to take care of that first. What do I do with a negative exponent? 1 over. So 1 over 9 to the 3 halves. Now, again, I have a fractional exponent. So that means I'm going to have a radical. So it's 1 over the radical. 9's in the radical, and it's the square root cubed. Square root cubed. So what's the square root of 9? Cubed.
27.
27. So 1 over 27. Cubed. When we say 3 cubed, we mean 3 times 3 times 3. Right? You don't necessarily have to have that memorized, although you probably should. But you can figure it out. 3 times 3 times 3. All right. This is the tricky one. This catches kids over and over again. You see that negative exponent, and you know you're going to do 1 over, right? But 1 over what?
2x.
Over 2.
Just the x. Does this 2 have a negative exponent?
No.
No, so he stays 2, and then that becomes 1 over x to the 5th. Do y'all see what I'm talking about? Be careful. You only do 1 over when it's got a negative exponent. This does not have the negative exponent, only the x does. So this is 2 over 1 times 1 over x to the 5th, 2 over x to the 5th. Okay, pay attention. Only move things when they have a negative exponent. Now, look at this next one. See how we are in parentheses now? So that means the whole shebang is going to the bottom because the whole thing is to the negative power. So it's going to be 1 over. Now, since the whole thing's in the parentheses and getting all cubed, we're going to have to do 3 cubed, which is 27, and then x cubed. This one doesn't have any negatives or any fractions. We just need to simplify. Okay, so what do you want to do with it? Nothing's moving around. Nothing is like radicals or anything. We just need to straight up simplify it. So what's 2 over 6? What's 2 over 6? 1/3. What's x to the 4th over x to the 1st?
X to the 3rd on top.
X to the 3rd on top. What's y cubed over y to the 5th?
Y squared on the bottom.
Y to the 2nd on the bottom. Technically, you don't have to write this one if you don't want to. It doesn't hurt anything to write it, but it isn't necessary. So don't feel like you have to write it. All right, just a few more. Alright, so 3/4 squared. Now again, no radical, no flipping around, we're just straight up gonna square 3/4. So 3 squared is 9, and 4 squared is 16, and we are done with that problem. Now the next one has a negative exponent. So what does that mean? We have to flip it first, so it'll become 4/3 squared. Right? And now we'll just square everything, so we end up with 16 ninths. Does that make sense? That one was 9/16, so we put a negative on it and it made it 16 ninths. Doesn't that make sense? 1/3 times 9 squared. Please don't let problems like this throw you off. What's 9 squared? 81. So this is 1/3 times 81. So it's 81 divided by 3?
27.
27. Wow. So what's going on here? First of all, does anything in here simplify? Nope, nothing cancels, right? They're all different letters and everything. So what do we need to do? So it's a big giant radical. It's a square root to the first, and all that's underneath it. Square root everything. What's square root of 16? 4. Oh, I don't know square root anymore. Square root of 16 is 4. Square root of 9 is 3. So I took care of that. Now, the square root of x to the 4th. You don't take the square root of 4. You take half of 4. That's right. You said you take half. You take half of 4. Because this is a 1/2 exponent and you are multiplying the exponents. So what's half of 4? 2. What's half of 2? 1. What's half of 6? 3. We don't square root exponents. We have them. Cut them in half. Good job, Jude. All right, we'll finish this column, and then that's it. That's all the review we'll do of these exponents. So next we have this. Now I don't have any fractional exponents, but I do have a negative exponent. What in the world am I gonna do with that guy right there? He's coming down to the bottom. So 4y squared over 8xy to the 10th, and then x cubed down there? Is there any kind of simplifying? There's no radical, so don't do any of that. But is there any kind of just plain and simple simplifying I can do?
1/2.
4 over 8 is 1 over 2. How about y squared over y to the 10th?
Y to the 8.
Y to the 8th on the bottom.
And then x 4.
And then how many x's do we have all together? These are all on the bottom now.
4.
So you got 1 and 3, you got 4. There's your answer. What's 2 to the negative 4th mean? Means 1 over 2 to the 4th. And 2 to the 4th is?
16.
16,
Yes.
so 1 over 16, perfect. 100 to the 3 halves.
Radical.
This is gonna be a radical. And under the radical is going to go 100.
Square root of 102.
It's gonna be the square root to the 3rd power. Right? You were calling this from yesterday, you need to know this. So the square root of 100 is 10. And 10 cubed means 10 times 10 times 10, which is 1,000. Last one in this column, 8 to the negative 2/3. First of all, there's a negative. Take care of it. So what do we do with it?
1 over 8.
1 over 8. Remember, we do not mess with the exponent. Just make it positive. No flipping exponents.
Radical.
So that's gonna be a radical. Gonna have an 8 under it. And it's gonna be the cube root squared.
2 squared.
Cube root of 8 is 2, and 2 squared is 4. So 1 over 4. Okay, now, there's a whole nother column here. The answers are on the back, so if you wanna practice, you can, the answers are all on the back. Now, there is another sheet, don't worry about that one yet, we haven't finished all that yet, so don't worry about all that. We just use this top sheet, if you wanna practice, there are a whole bunch of them there for you to practice. Okay, now we need our calculators. Today we're gonna do calculator work.
Oh no, I don't know what my computer is.
And the first couple of problems, I don't wanna mess around going to the book and finding them, so I already did that. So, your job I'm looking at 3.2 number 1. Here are the 2 ordered pairs. And your job is to do exactly what we were doing yesterday. Write the equation of the exponential. Okay, now those directions aren't there, so you don't have to write down. We're gonna write the equation of the exponential. And I have given you these 2 points. So it's just like we did yesterday. Who remembers what we did yesterday? We had to write the equation of the exponential. Alex?
So you did the y, then you equal that to AB,
Yes.
To the
to the
x power.
to
So
the power
this
of x.
is our goal. This is the equation we want to write. So how do we start figuring out our A and B?
We'll get in the X and Y for the first, for the
Start
one with 0.
this point right here. Kids, so seriously, going through these, we did a whole bunch of these yesterday. Pick the point that has the 0 in it. So negative 5.8 equals A times B to the 0. And what did we decide about B to the 0?
It's 1.
It's 1. Anything to the 0 is 1. So A is negative 5.8. So now my equation is y equals negative 5.8 b to the x. Okay, this is exactly what we did yesterday, only the numbers are worse, so we're gonna use our calculator. So what happens now? What do I do next?
Plug in
Plug in for A and take the other
Plug
points.
in this y
X.
and this x.
Yes. And then we find the
Now, what's b to the first?
B.
Just b, so I don't really need to worry about that exponent. How do I figure out what B is then?
Divide by
Divide,
-0.8.
so I'll take my 4.64 and divide it by 5.8. Did you get 0.8?
Yep.
So then you're ready to write your answer, which is y equals negative 5.8 times 0.8 to the x. Do you remember this from yesterday now, folks? Okay. All right. One more of those, only here's what you're given this time. You're given a picture, so I'm on problem B now. Here is the picture that you are given. You're going to have to draw this picture because it's in the book, and I didn't run off the whole problem. So here's the curve. Your job is to write the equation of that curve. You're supposed to recognize that that's exponential. Now, the normal exponential, the one you memorized, looked like that. This is just the flip of it. Instead of growing, it's decaying. But the equation is still going to be a times b to the x. So instead of just handing you 2 points, you have to get them from the picture, but they're right there. So what do we start with?
The 0 and 3.
That one right there? So 3 equals a times b to the 0th, which means a equals 3. So now our equation looks like y equals 3 b to the x. Okay. Now what?
Plug in the other side.
I hear mumbling, I can't understand any of it. What?
Plug in the other side.
Plug in the other point. This is an x and a y, right? So 1.49 equals 3b to the 4th? So what do I need to do?
Divide.
Divide by
3.
3. So 1.49 divided by 3,
0.496.
0.49, no, let's round that off to 67. Do 1.49 divided by 3, see if you agree with this decimal. It goes on forever, so I'm gonna round it off. Is that all right with everybody? And that's b to the 4th. How did we do this yesterday? When it was b to the 4th equaled something, what did we have to do?
Key rooted.
Well, 4th root it, right?
Yeah,
I have
yeah,
to
4th root, my bad.
whatever root that is, that's what I need to do. So I'm gonna 4th root both sides. Now yesterday, these were like 16, and we knew it. The 4th root of 16 is 2. No one knows the 4th root of this, right? So that's what we need our calculator for. So everybody's listening, and I'm gonna tell you how to type this in on a calculator. If you want to take, obviously we have a square root button, so whenever you're square rooting, you just use your square root button. This is a 4th root. So you press 4, first of all, press 4, that's this, whatever this root is, you press that first. Then you go press your math button, look where my finger is, it's on the math button. And if you look down the list, there is an X root button, for me it's number 5. You see it? Press that, and then type in your 0.4967, and press equals, and it's what, about 8.4 or 0.84?
Yep.
Roughly. So you can take whatever root you want on your calculator by pressing the root number first. You have to put that number in first. Then go to math, choose the X root, and then type in your number. So what is the answer to this problem? Y equals 3
3
times 0.84
to the X
to the X power. Now, quickly, I want to tie this to something else we talked about yesterday. Clearly, this is a decay problem, right? I mean, look at it. Aren't we shrinking? Look at your equation. Does that jive with what we talked about yesterday?
Yep.
If that number is less than 1, you're decaying, right? And this would actually be a 16% decay because 0.84 is 0.16 less than 1. How much less than 1 is your percentage? How much more than 1 is your growth percentage? See how it all fits together?
Yes, ma'am.
Yep. All right. So speaking of all fitting together, now you're going to write an exponential function, but the given is different. Okay? So I want you to think a minute about, I just erased it, but that equation was 3 times 0.84 to the X. And we said that was a 16% decay, and the initial value would be 3, the y-intercept, okay? Now, number 2 says you're gonna do the same thing. They give you an initial value that's 4, so we're gonna start with 4. And they're telling you that you are increasing 11%. Increasing. So this will be 1.11 to the X. Done. That's it. That's it. You know where you're starting and you know how much you're increasing. That's your answer. Next, the initial value is 0.36. And we're increasing 22%. So what will go here?
2.2.
We're increasing
1.22.
22%.
1.22.
1.22. Is it 22% 0.22?
Yep.
Yeah. So this is 1 plus 0.22. Now be careful on C. The initial value is 147, but now we are decreasing, decaying. So what's gonna go here if we're going down 10%? 0.9, that's exactly right, 0.9 or 0.90. Remember, 1 is your starting point. If you're increasing, you add to 1. If you're decreasing, you subtract from 1. D, initial value is 20.8. And I am decreasing 4.5%. 0.955. And for those of you that are wondering where she got that, it's 1 minus 0.045. 4.5% is 0.045. And a decrease is 1 minus that amount. All right, and finally E, 16/3 times what? We're decreasing 42%.
0.58.
0.58. 0.58. Now, we're gonna actually do a problem. So the population of Calcville was 123,000 in the year 2000. It decreases 2.5% each year. What is its population in 2010? Well, let's write the equation first. Where did the population start? What is our initial value? 123,000. So that's our initial value. Now, what is this population doing? Decreasing 0.025. Would you agree? Okay, so if we're decreasing 0.025, then what's gonna go in the parentheses? 0.975. For those of you that are confused, 1 minus 0.025. 1 minus the decrease, or 1 plus the increase if it's growing. Okay? Now, this problem, I know what X is. How many times am I decreasing? Well, I'm going from 2000 to 2010 every year, so that will be 10 years. This exponent is 10. Our decrease is happening every year, and it's happening for 10 years. So then I just type it in on my calculator. 123,000. 0.975 raised to the 10th power. I got 95,489 people.
Oh, yeah.
Keep in mind, this is a people problem, so we don't want any decimals. So I rounded to the nearest person. Isn't that easy?
Person problem you always round down?
You round to the nearest person, so I actually rounded up on this one, yeah.
Thank you.
All right, everybody type that in and get it? You have to know how to type these in, okay. B, the population of Trigville was 9876 in 2005. It increases 12% a year. What's the population in 2013? Okay, so wait a second. My equation's gonna be 9876, that's my starting, right? What am I multiplying it by? 1.12, because it's 1 plus 0.12. And how many years am I letting it go?
8.
8. So just type it in. 9876. 8. I got 24,453. All right, got it? Okay. 3.2, done. Homework due Thursday. Now the moment you've been waiting for. Got a whole page of logarithms. All right, so no, put the calculator away, don't need them for these. Okay, so I want you to write something down up at the top of the paper. You got some room up there in the upper margin. I want you to write this down. The log base b, that's a b, of b to the n is n. That is a property of logarithms. It says as long as these two numbers match, the answer will be whatever the exponent is. Okay? So the log base 12 of 12 to the 5th would be 5. Okay, the log base 9 of 9 to the 8th would be 8. As long as these two numbers match, the answer is the exponent. So now, look at this problem. Do these two numbers match? What's the exponent here? A 1. So what's the answer to the question? 1. It is that easy, folks. That easy. Now, log base 4 of 16. Now be careful. Do these two numbers match? No. But can we make them match? What do we know about 16?
Cube root.
It's 4 to the second, isn't it?
Yes.
So what if we wrote this as the log base 4 of 4 squared? Then, no, it's not 4.
It's 2.
Then it's 2. Remember, if these two numbers match, that is the answer. If those two numbers don't match, then we try to make them match. It gets more complicated if we can't make them match. So look for, like, is 16 a power of 4? Yes, it is. It's 4 squared. Now, wait a minute. Wait a minute. What in the heck is this LN thing? You did them last year. That's an LN, not a 1N. That's an LN. LN is the symbol we use for log base E. You know how your exponential was e to the x?
Yeah.
And one of your BFFs was lnx? That was the symbol. Ln is the symbol for log base E. And they call it Ln because these are called the natural logarithms. So Ln, the natural logarithms. So anytime you see an Ln, think of it as log base E, because that's what it is. This is the symbol for log base E. So what's log base E of E cubed? 3. Because when these two numbers match, the answer is the exponent. Number 4. What's wrong with that?
There's no base.
There's no base. Actually, there is, because LOG is the symbol for log base 10. Anytime you see an LOG with no base, you know it's a 10. These are called common logs. They are so common that we don't put the base in. It's like this symbol. What does that symbol mean?
Square root.
Square root. Do we have to write the 2 there? No, because we use it all the time. So we just understand there's a 2 there. Well, we use this all the time. We just understand that there's a 10 there. So now we've got the log base 10 of 1,000. Now, these numbers don't match. Is 1,000, can I rewrite this as the log base 10 of 10 to a power?
10 cubed.
Is 1,000 10 to a power?
10 cubed.
It's 10 cubed. So the answer to this problem is also 3. If you do not have a calculator, if you are not allowed to use a calculator, you have got to make these two guys match, which means you've got to rewrite that number as a power of this. Now, just for fun, take your calculators out and type in log 1,000. Hit log, use your LOG button, log 1,000. What's it say?
Oh, it's 3, that's all.
Isn't that amazing? You just figured that out without a calculator.
I got 2.
If you didn't get 3, you didn't type it in right.
Where's the log
LOG 1000 is
To the
3.
left
Log,
of that.
it says log, like, you know, class your hours.
You have a button that literally says LOG on it. Alright, here we go. Log base 4 of 116.
That's not pretty.
Now, I just told you that these two numbers have to match. They don't. But 16 is not a random number where 4 is concerned. What's 16?
4 to the negative 2.
Well, 1/16 is 4 to the
Yeah.
negative 2. So he said, and you process this however you process it, but he said 16 is 4 squared. I can't have that 1 over thing in there. But I know that 1 over is a result of having what kind of an exponent? Negative. So this is the log base 4 of 4 to the negative second. We're working backwards. On the problems we practiced yesterday, we took 4 to the negative second and made it 1 over 4 squared. Well, now we have 1 over 4 squared and we're turning it into this. So we can cancel those and the answer is negative 2.
Looks a lot scarier than it is.
It looks a lot scarier than it is, that's exactly right. Okay, ln 1 over e cubed. Well, first of all, what does ln mean? Log base e.
So it's -3, baby.
Now, this is 1 over. Where do 1 overs come from? Negative exponents.
So log base
So
e.
isn't this e to the negative third? Isn't e to the negative third 1 over e cubed?
Oh, yeah.
Working backwards. So now we have log base e to the negative 3, those cancel, and the answer is negative 3. One of those crazy things, logarithms and radicals do not get along. So if we are in logarithm land, we don't want radicals. So I want you to think about, what does a cube root mean in terms of an exponent? It's a fraction, and what fraction would it be? 1 over 3. So this is the log base 6 of 6 to the 1/3. Before you start freaking out, 6 to the 1/3, doesn't that mean the cube root of 6?
Oh, yeah.
But we need to write it this way so that these will cancel, and we can see that the answer is 1/3.
Is that a 1 or an L?
1. Now, keep in mind that this is the rule that we are living by right now. All right, that's a biggie. That's a big rule. But in order to use that rule, that can't be a 1, that has to be a 4. So log base 4 of 4 to some power. Well, 4 to what power makes 1? 0.
Oh.
0. Because anything to the 0 power is going to be 1. 4 to the 0 is the same as 1. Now they match, so the answer to the problem is 0. Now 9 is much easier. 9 is an easy one. You should be able to figure out 9. Log base 7 of 49. You need it to be the log base 7 of 7 to a power. What power?
7 squared.
Second. So the answer is 7 squared is another way of writing 49. Right? Alright, log 1/10. Now, two things. First of all, when you see LOG, you know the base is 10. Now, you need this to be a 10. It's a 1 over -1. This is the log base 10 of 10 to the negative first, so it's -1. Remember, 1 over gives us negative exponents. So I have 1 over 10. That's 10 to the negative first. These are the same now, so the answer is -1. Would you try the next one? See what you can figure out with that guy. You don't have to overcomplicate it. If you think you know the answer, you can just say it. It's -2. The answer's -2. Now, here's what you should could be thinking about. Is 9 a power of 3?
Yeah.
9 is 3 squared. But it's 1 over, so it's 3 to the negative square, or negative second. So this is the log base 3 of 3 to the negative second. Anytime it's 1 over, you're going to make it negative. All right, try this one. This one's easier. The log of 100.
2.
10.
I heard somebody say 10.
10.
10 is wrong.
2.
I heard somebody say 2, and 2 is wrong. Remember, the base is 10. 100 is not 10 to the 10th. 100 is 10 to the second, isn't it? So the answer to that problem is 2. Anybody know what 13 is? 1. Yeah, log base 6 of 6 to the first. That's just 1. What if it were log base 7 of 7? 1. Log base anything of that number is going to be 1. Yep, every time. Spend a minute with 14. What do you think about 14? I heard a 2.
1 over 2.
What?
1 over 2.
1 over, I heard a 2 and I heard a 1 over 2. Oh wait,
It's a
which one am I
7.
doing?
Half base 7.
Log 7, square 7.
So radicals do not live in logarithm land. So you got a square root, change it to an exponent. What is the exponent for a square root?
1/2.
1/2. And as soon as you do that, you know your answer. These match, so the answer has to be 1/2. What if this had been a cube root?
Then it'd be 1 over 3.
Then would this be 1/3? The answer would be 1/3. All right, a couple more, then we'll pause a minute and look at some homework problems. All right, ln e to the 10th. Easy
N
peasy.
equals 10.
Log base e of e to the 10th, the answer is just gonna be 10. How about ln cube root of e? You're getting the hang of it. She said 1/3, she's not even working it out. This is log base E of e to the 1/3. Cube roots are 1/3. Think about 27 to the 1/3. We did that yesterday. And we said, okay, that's a radical. Cube root to the first. So 27 to the 1/3 means the cube root of 27. This means the cube root of e is e to the 1/3. So the answer is 1/3. Anybody want to throw out an answer to 17? What? -1? Because it's log base e of 1/, and anytime you have 1/, your power's gonna be negative. So this is log base e of e to the -1st. So it's -1. You were right, you said -1. All right, that's a good place to pause because the next one looks totally wacky. So we'll stop there. I want you to get out your 3.2 homework. 3.2, which is due on Thursday. And I want to do the exponent problems at the bottom as we are preparing for a quiz. Note, no calculator. So we need to be able to do these exponent problems without a calculator.
Wait, what is this?
This is 3.2 homework, problem 3, simplifying without a calculator. So, what do? Get yourself out. It's in the logarithm. We're out of logarithm mode. We're now in exponent mode.
Flip it.
What do we do?
Flip it.
Flip it. We
2/3.
flip it to 2/1, or just 2. I don't care which way you write it. And then the exponent becomes positive. So the answer to the problem is 8. Next. Do you understand that you really need to understand this in order to do the logarithm work? So that's why we're doing this. So now I see a fraction. A fraction exponent is a radical. Underneath is 27/8, and it is a cube root, third root, cube root to the first. What's the cube root of 27? 3. What's the cube root of 8? 2. There's the answer to the question. Now in the logarithm work, you start with the cube root and you have to rewrite it as a 1/3 exponent. These are the same thing. All right, 1681s to the -1/4. All right, so what do I do first?
Flip fraction.
Flip the fraction, not the exponent. The exponent just becomes positive. So 81/16 to the 1/4. That's a radical. 4th root to the first, and it's 81/16.
3/2.
4th root of 81 is 3, because 3 times 3 times 3 times 3 is 81. We've used that number a ton. And then the 4th root of 16 is 2. So it's 3/2. 27 to the 2/3. that'll be a cube root, it'll be a radical, right? Cube root squared. What's the cube root of 27? 3 squared is 9. Alright. This is due on Thursday, you've got 4 minutes, you can go ahead and get finished up, or already finished up. Probably turned in yesterday.
Yep.